So hello friends. So today I'm going to explain a very good example of partition and repartitioning. So I have already discussed this example in my previous video. So let me do it again. So there is a snapshot of how blocks in HDFS are loaded into Spark workers partition. So data is on the HDFS and but how it's loaded on to the Spark workers. So I have an image. This one I've already explained. The example is I have a 1 GB text file and which is distributed on 4 nodes. Okay, so will Spark use the same partitions? Spark loads same four HDFS blocks to works memory as partition. So I have a 1 GB file which is divided into four partitions. Yeah, I can say four HDFS blocks, so four partition will be there. Now, if I did the repartition for 1000, then what would happen? So shuffle 1 GB across the cluster when I call partition. Yes, Spark shuffle the data among the worker nodes in order to create 1000 partition in workers memory, not at the SDFS. So if I do a repartition over this data, then 1000 partition will be created on this worker memory. Now I'm going to explain two very important example, and sometime interviewer asks this example in your interviews. So let's say I have a cluster of 4 nodes and each having one core, right? I have 600 petabyte size big file which I want to process through Spark. File could be stored in HDFS. So how data partitioning and parallelism will be done by Spark? So I'm assuming that your HDFS block size is 128 MB. So if I divide this 1600 petabytes in by 128 MB, this will look like 1000 into 1000. So it will be 600 into 1000 GB. Okay, 1000 terabyte, then into 1000 GB and into 1000 MB divided by 128. So these many blocks will be there. Now, these many blocks means these many partition will be created. Now coming to your scenario, if you have a 4 node cluster with one core each, what does it mean? At a time, only one task can execute in your cluster. Now, from these 4 nodes, 3 nodes will be assigned to the executors and one node will be assigned to the Spark driver. So you will have three executors running on them, at max one core and one for driver. So overall, how many iterations will be there? If you divide these many blocks, if I say these many partitions, and at a time three partitions will be processed out of these many partitions, so you will have these many iterations to process the whole data. Okay, so parallelism means not, so it does not mean that if you say parallelism then all the partition will be processed. No, that depends on your resources as well. It, ideally this has these many partitions, so if you have a Spark cluster then these many partitions should be processed at a time. No, the number of resources, so ideally you have three cores, so at a time three, so at a time parallelly three tasks can execute, so only three tasks will execute. Okay, and my second question, I have a cluster with 4 nodes each with 16 cores using Spark. So how many cores will be there? 64 cores. I have an RDD which I have repartition, so it has 200 partition, hoping to increase the parallelism. When I do a transformation such as filter on this RDD, I cannot seem to get more than 64 tasks. So here interviewer asking that you have a cluster of 4 nodes and each have 16 cores. I'm assuming a driver is running somewhere else. And you have repartition your data into 200 partition. But when you execute the program, and you debug the program into drivers or executed logs, then you will see that only 64 tasks are running at a time. Why 200 tasks are not running? Because you don't have the resources to run 200 tasks. At a time, you can only execute 64 tasks. That is the correct behavior. When one iteration is complete for 64 tasks, in the next iteration, again 64 tasks will execute, and to the next iteration, remaining tasks will be executed. So this is the idea. So remember, it does not mean you are using the Spark, and it does not mean the parallelism. Parallelism means how many resources do you have and how many available partitions are there. So only those number of partition resources will execute parallelly. Okay, number of tasks which are executing cannot be more than the number of resources, number of available resources. So in my next video, I will explain about the relationship between partition, task, and codes. And this is also very important when someone asks you how many tasks will be there, how many stages will be there, and how many resources will be required. So thanks for watching. Please subscribe my channel.